Today we are going to learn 6th class 3rd chapter playing with numbers. In that mainly we are going to learn here divisibility rules. So what is divisibility rules? How it is help us in doing problems? I am going to tell you today. So the divisibility rules mainly useful to do the calculations or simplifications in very speed or simple. So these divisibility rules useful to do the simplifications in easy method. So here let us start our class with the divisibility rule of 2. Divisibility rule of 2. So what is the divisibility rule of 2? So if the last digit or in the unit place of digit, if it is a even number, then the number is divisible by 2. In a given number, in the unit place digit or the last digit, if it is a even number, then the number is divisible by 2. Or else in the unit place, 0 r, 2 r, 4 r, 6 r, 8. These are all even numbers actually. So in the unit place, if any one of these digits in the unit place, then the number is divisible by 2 or else it not divisible by 2. Okay, let me tell you some examples here. For example, let's see here 256. Is it divisible by 2? Yes, clearly it is divisible by 2. How we can say? Here the last digit is even number, that is 6. So when 6 is divisible by 2, then this whole number is divisible by 2. Okay, let me tell you now. 1, 5, 6, 7, 8, 3. Is this number is divisible by 2? No, this number is not divisible by 2 because here it is not, the unit place digit is not a even number, it is a odd number. So hence it is not divisible by 2. Now it is a divisible by 2 because the unit place digit is 0. Hence here this 0 is divisible by any number. In the same way 0 is also divisible by 2. So I hope you understand that if a number is divisible by 2 or not, how to identify? We have to see the unit place digit. If it is a even number, definitely the number is divisible by 2. And next we have to learn divisibility rule of 3. Divisibility rule of 3. Here divisibility rule of 3 is sum of all the digits of a given number. The sum of all the digits of a given number. If it is a multiple of 3 or it is a divisible of 3, then the whole number is divisible by 3. The sum of all the digits of a given number. If at all it is a multiple of 3 or else the sum of all the digits, if it is divisible by 3, hence the number is divisible by 3. Let me give you one example here so that you can understand. 2, 5, 3. Let me check this 253. Is it divisible by 3? I don't know. So let's go for that. Our rule of divisibility by 3 is that sum of all the digits in the given number. Let us add these digits. 2 plus 5 plus 3. So what will we get? 2 plus 5 is 7. 7 plus 3 is 10. Here 10 is not multiple of 3. Or else this 10 is not divisible by 3 exactly. So and this 253 is not divisible by 3. Here we can know. Let me tell now. Let me give you now. Okay. Now let's see this number is divisible by 3 or not. Okay. Let us find out the sum of these digits. 1 plus 5 plus 3 plus 6 plus 9. That equal 1 plus 5 is 6. 6 plus 3 is 9. 9 plus 6 is 15. 15 plus 9 is 24. As this 24 is multiple of 3. 3 8s are 24. Or else this 24 is exactly divisible by 3 without giving a remainder. So this complete number is divisible by 3 now. So I hope you understand that what is the divisibility of 3. If sum of all the digits, if it is divisible by 3, then the complete number is divisible by 3. Now, just now we have learned the divisibility rule of 2. If a unit place digit is 2 or 0 or 4 or 6 or 8, any one of these digits in the unit place, then the complete number is divisible by 2. And divisibility rule of 3 is that sum of all the digits, if it is divisible by 3, then the complete number is divisible by 3. Then here, divisibility rule of divisibility rule of 6 now. So I will tell you what is divisibility rule of 4 and 5 also. If you learn in this way, you can remember in a very easy way. So divisibility rule of 6. What is the divisibility rule of 6? If a number is divisible by 2 and 3 both, then the number is divisible by 6. If a number is divisible by 2 and the same number is, if it is divisible by 3 also, then the number is divisible by 6, or else it is not divisible by 6. So if a number is divisible by 2 and 3 both. If a number is divisible by 2 and 3 both, then the number is divisible by 6. Let me give you some examples. See that here 252. 252. Is this number is divisible by 2? Let us check. Is this number is divisible by 2 or not? Yes, last digit is 2, even number. So it is divisible by 2. And is this number divisible by 3? Let us check. 2 plus 5, 7. 7 plus 2 is 9. Yes, 9 is divisible by 3. So this number is divisible by 2 and 3 both. So this number is also divisible by 6. It's also divisible by 6 exactly without leaving a remainder. So here we need to understand, if a given number is divisible by 2 and 3 both, then it is divisible by 6. Already we know the divisibility rule of 2 and divisibility rule of 3. So easily we can identify a given number is divisible by 2 and 3 both or not. Must and should we need to be remember here, the number should be divisible by 2 and 3 both, not only one number. Let me give one example now. 251. Is it divisible by 2? No, it is not divisible by 2 because the unit place digit is not a even number. Is it number is divisible by 3 now? It is also not divisible by 3. So this number is not divisible by 6. Now let me give you one number now. Yes, 16. Yes. Now see, in this case, this number 2 plus 5, 7, 7 plus 8, 15. 15 is divisible by 3. And the last digit is 2, it is also divisible by 2. So now let me give you one more number. 27 suppose. Is this 27 is divisible by 2? No. Is it divisible by 3? Exactly, it is divisible by 2. 3. 2 plus 7 is 9. 9 is divisible by 3. So see that this 27 is divisible by 3. It is not divisible by 2. Hence it is not divisible by 6. If a number is divisible by 2 and 3 both, then only it is divisible by 6. This thing you need to remember. If it is divisible by 2, it is not divisible by 3, then it is not divisible by 6. If a number is divisible by 3, it is not divisible by 2, hence it is also not divisible by 6. It must and should divisible by 2 and 3 both. Okay, next let us learn about divisibility rule of 5. Divisibility rule of 5. Very simple. The divisibility rule of 5. Here the divisibility rule of 5 is that if a number, or else we will learn the one more divisibility rule, that is divisibility rule of 9. Simple. Why I am taking here divisibility rule of 9? Because here divisibility rule of 3 we know, that is sum of the all the digits. No? Here also same, the sum of all the digits. It will be in order, sum of all the digits. See. So what is, if a given number, if they have given one number, we have to add all the digits in the number. The sum of all the digits of a number. If it is multiple of 9, or it is divisible by 9, then the whole number is divisible by 9. Let me tell you one example here. I will be giving you here 5, 6, 8, 3, 7, 2, 9. Let me check this. Is this number is divisible by 9 or not? So 5 plus 6 plus 8 plus 3 plus 7 plus 2 plus 9. What are the sum of these digits? 5 plus 6 is 11. 11 plus 8 is 19. 19 plus 3 22. 22 plus 7 29. 29 plus 2 31. 31 plus 9 40. Is this 40 is divisible by 9? No, it is not divisible by 9. So this complete number is not divisible by 9. So let me take one more number here. Then I will take one more example. Instead of here 40 is not divisible, 35. So I have to remove 5 here. Let me take here 4. One more example, 4. So let us add now. Let us add. See that what you will get the sum now. 5 plus 6 is 11. 11 plus 8 is 19. 19 plus 3 22. 22 plus 7 29. 29 plus 2 31. 31 plus 4 35. Okay, is this 35 is divisible by 9? No, it is also not divisible by 9. 35 is not divisible by 9. So what number is divisible by 9? Let's see here. If you write here 5. If you write here 5, one more number is increased, no? So one more number is increased. So here you will get 36. Is this 36 is divisible by 9? Yes, exactly this 36 is divisible by 9. So complete this number is divisible by 9. I have given 3 examples here of the same number by interchanging one digit only. But here we can conclude that only one thing, if sum of all the digits, if it is divisible by 9, then the complete number is divisible by 9. Okay, here also same, the divisibility rule of 3. If they have given a number, if the sum of all the digits, if it is divisible by 3, then the whole number is divisible by 3. So here we need to be discuss about the divisibility rule of 9 and also divisibility rule of 3 here. Okay, divisibility rule of 3 and divisibility rule of 9 we have to discuss here. So here one thing you need to remember, if a number is divisible by, let us write one here, 2, 5, 2. Is this then 9 plus 3, 12. Okay, then find out the sum of these is 2 plus 5 plus 2 plus 3, that is equal to 7, 7 plus 2, that is 9, 9 plus 3, 12. Okay, this 12 is divisible by 3 exactly. Okay, this 12 is exactly divisible by 3. You are the 3 fourths. So see that if a number is divisible by 9, it's also divisible by 3. If a number is divisible by 9, it's also divisible by 3. See that this number is divisible by 9. The sum of all these digits is 36. The 36 is divisible by 9. Hence, this complete number is divisible by 9. This complete number is divisible by 9. Okay, here need not to be check that either it is the division process is not required. Only that if the sum of all the digits is divisible by 9 or not. Just sum of all these digits is 36, that is divisible by 9. So this complete number is divisible by 9. If a number, see now, this number is divisible by 9. So this number is also divisible by 3. Simply you need to remember, if a number is divisible by 9, it's also divisible by 3. But if a number is divisible by 3, it may divisible by 9 or may not be divisible by 9. Sometimes it's possible it is divisible by 9, sometimes it is not divisible by 9. That we need to check it. But in the case of if a number divisible by 9, we need not to check, definitely it is divisible by 3. But if a number divisible by 3, we need to check either it is divisible by 9 or not. Yes? Okay, for example, see, the sum of all the digits is 12. 12 is divisible by 3. But the sum of all the digits is 12, is not divisible by 9. In this case, you can understand. So, suppose let me write one more example. 252. The 252, 2 plus 5 plus 2, that is equal to 9. Yes, this 9, sum of this 252 is divisible by 3 and also it is divisible by 9 both. So in this case, so if sum of the all the digits is divisible by 9, then it is divisible by 3 definitely. But if a sum of the all the digits divisible by 3, we need to check that either it is divisible by 9 or not. Sometimes it is divisible and sometimes it is not divisible. There we need to check. Okay, but we need not to check that in the case of it is divisible by 9. It's definitely divisible by 3. Okay, this is the thing you need to be remember. Okay, now next we need to be discuss about divisibility rule of divisibility rule of 5. Now I go for divisibility rule of 5. If a unit place digit of a given number, if a unit place digit of a given number, unit place digit is 0 or 5, any one of these digits, these digits 0 or 5 in the unit place of a given number, then the number is divisible by 5 or not, it's not divisible by 5. Very easily we can identify. Let us see. Suppose I have given one number here 250. Is it divisible by 5? Exactly divisible by 5 because the unit place digit is 0. Let me take a second example 255. Is it divisible by 5? Definitely it is divisible by 5. The unit place digit is 5. Now let me take a one more example now 2537. Is it divisible by 5? No, it is not divisible by 5 because the unit place digit is neither 0 nor 5. Neither 0 nor 5. So if a unit place digit is 0 or 5, then the number is divisible by 5. Otherwise it is not divisible by 5. Now next divisibility rule of 10. The divisibility rule of 10. Unit place digit must be 0. Then only the number is divisible by 10. What is the divisibility rule of 10? The unit place of a given number, if it is 0, then the number is divisible by 10 or else it is not divisible by 10. For example, see, only the unit place must be 0. Other than 0, if any number is present at unit place of the given number, hence the number is not divisible by 10. So let me write here 573. It is not divisible by 10. Okay, 500. It is divisible by 10. 570. It is divisible by 10. So easily we can identify if it is unit place of digit, first digit. If it is 0, it is divisible by 10. Otherwise it is not divisible by 10. Here also we need to be understand one thing. See, if a number divisible by 10, it's also divisible by 5. If a number divisible by 10, it's also divisible by 5. Suppose, for example, see 150. Suppose this 150, it is divisible by 10. Yes, it is divisible by 10 because the unit place digit is 0. So, is it divisible by 5? Yes, it's also divisible by 5. If a number is divisible by 10, it's also divisible by 5. We need not to check once again. Suppose 150 number is divisible by 10. Need not to check either it is divisible by 5 or not. Definitely it will divisible by 5. But that in the case of like same as we discussed like divisibility rule of 9 and 3. If a number is divisible by 9, it's also divisible by 3. We need not to check that. If a number is divisible by 3, we have to check either it is divisible by 9 or not. It may divisible or may not be divisible sometimes. So here let me take one example 155. So this number is divisible by 5. Is this number divisible by 10 now? No, it is not divisible by 10. So in this case, if a number is divisible by 5, we have to check either it is divisible by 10 or not. It may divisible or may not be divisible. Suppose I will be giving one example here. Suppose 150. 150 is divisible by 5 and it is also divisible by 10. Same. Or not? Suppose 370. 370 is divisible by 5. It is also divisible by 10. So here, if a number divisible by 5, this is a divisibility rule of 5 and this is divisibility rule of 10 for examples. So in this case, a In the divisibility rule of 5, see this 155 divisible by 5. So there is no rule such like that. If it is divisible by 5, there is no such a rule that it must be divisible by 10. No. So if a number is divisible by 5, we have to check either it is divisible by 10 or not. It may divisible sometimes when the unit place is 0, and it will not be divisible by 10 when it is the unit place is not 0. Okay, but in the case of divisibility rule of 10, if a number is divisible by 10, definitely it is divisible by 5. This thing you need to be remember. Now see that how many divisibility rules are completed, like 2, 3, 6, 9, 5 and 10. So the next two are divisibility rule of 4. If the divisibility rule of 4, what is the divisibility rule of 4? The sum of last two, the last two places of a given number. That means ones place and tens place of a given number. If it is divisible by 4, then the whole number is divisible by 4. Okay, last two places of a given number. If last two places have a given number, that means unit place and tens place of number, we have to observe. Whatever the big number, we do not to see the complete number. If the last two places of a number, that means unit place and tens place of a number, if it is divisible by 4, then the complete number is divisible by 4. Or if the last two digits are 2 zeros, then it is directly divisible by 4 also. Let me write some examples here so that you can understand that. Suppose 200. Here last two digits are 0, so it is divisible by 4. Definitely it is divisible by 4. So let me write now here second example, 5, 6, 7, 3, 2, 4. Okay, this is a very big number now. 5,67,324. Is it divisible by 4 or not? To check that, last two digits we take. What is the last two digits? That is 24. If this 24 is divisible by 4, exactly it is divisible by 4. 4 6 is 24. That means it is divisible by 4. So if last two digits of a given number, if it is divisible by 4, then the whole number is divisible by 4. Or not, if last two digits of a given number is 2 zeros, then it is divisible by 4. So divisibility rule of 8 also very similar to this divisibility rule of 4. Let me tell you that also. Divisibility rule of 8. The divisibility rule of 8 here. Last three digits here. Last three places of a given number. Or not, last three places are 3 zeros, then the number is divisible by 8. Okay, let me write here some examples. See that here 5, 6, 2, 7, 3, 5, 1, 2. So this is a very big number. Let us see, is this number is divisible by 8 or not? How to check? We have to check only last three digits. The last three digits are 512. Is this 512 is divisible by 8 or not? Let us check. Okay, 8 6 are 48. 3 left, and here let us bring down the 2, that become 32. Okay, 8 4s are 32. Yes, it's exactly divisible by 8. So this complete number is divisible by 8. Very simple. If last three digits are divisible by 8, then the complete number is divisible by 8. Last three digits of a given number, that means the unit place, tens place, hundreds place of a number. If it is divisible by 8, then the complete number is divisible by 8. Or not, if last three digits are 3 zeros, we need not to check, definitely it will be divisible by 8. So here also we need to be check one thing here. So as we discussed that divisibility rule of 9 and 3 and divisibility rule of 5 and 10. Here also divisibility rule of 8 and 4. If a number is divisible by 8, it's definitely divisible by 4. If a number divisible by 8, definitely divisible by 4. But if a number divisible by 4, it may divisible by 8 or may not be divisible by 8. We need to check it once. So I hope you understand. If a number is divisible by 8, definitely divisible by 4. But if a number is divisible by 4, it may divisible by 8 or may not be divisible by 8. Okay? I hope you don't require the example for this. Now next, which numbers are missing? Can you tell me now? Your 2 is completed, 3 completed, 4, 5, 6 completed, 7 is missing, 8 came here, 9 and 10 completed. So remaining 2 divisibility rules we need to learn. That is divisibility rule of 7 and divisibility rule of 11. So these 2 we need to be learned to complete these divisibility rules. Because in the 6th class we have only divisibility rule of 2 to 11 only. So these 2 we need to be learned. Okay, let me tell you that divisibility rule of 7. Divisibility rule of 7. This divisibility rule of 7 is little we need to understand the difference of twice of the last digit and the remaining digit. If it is divisible by 7, then the whole number is divisible by 7. The difference of twice of the last digit and the remaining digits. The difference that means subtractions of the difference between the twice of the last digit, that means twice of the unit place digit and the remaining digits. If it is divisible by 7, then the whole number is divisible by 7. So for example, let me write here. Suppose here 743. Let me check that 743 is divisible by 7 or not. I don't know. So twice of the last digits. So here we have to divide this complete number into 2 parts. The last digit is 1 part and remaining all digits are 1 part. Okay, the last digit we have to make it twice. Here there is a 3. So twice of the 3, that means double of 3 is 6. That 6 need to be subtract from the remaining digits. Here the definition. Difference between the difference is minus. So remaining digits are 74. So twice of the last digit is what? That is 6. Their difference let us find out here. Okay, here 14, that means here 6, here 14. 14 minus 6, that is 8 and 68. Is this 68 is divisible by 7? No, it is not divisible by 7. As the complete number is not divisible by 7. So let us check that 343. Is this number is divisible by 7 or not? What we need to do it? Here we have to divide it into 2 parts. Unit place digit is 1 part. The remaining all digits are 1 part. Let us check. Now here this 34 and twice of the last digit is 6. Let us check. So here this become 2 and 14. Here 8. Okay. Here 6, 8 and 2. 28. Is this 28 divisible by 7? Exactly. 28 is divisible by 7. 7 4 the 28. 7 4 the 28. Yes. So here is divisible by 7. See that twice of the last digit. The difference is we are finding the difference here. See, I am subtracting the difference between the twice of the last digit. The last digit we have to make it double, and that number we have to subtract from the remaining digits. And this process we have to be continue until the last, until the final. Then only the number is divisible by 7 or not, we can tell that. So to understand you more better way, let me take one example here. Let me take one example from the textbook so that you can understand that either the numbers are divisible by 7 or not. Let me take one big number. Until that time, you will see that what we have discussed till now, the divisibility rule of 2, 3 and 6, divisibility rule of 9, and also divisibility rule of 5, 10, and also divisibility rule of 4, 8, and the divisibility rule of 7 we are discussing now. So, should we give one example for you, the divisibility rule of 7 or not? Let me take one example here. Yes. Okay. Then here 5, 3, 7, 6, 3, 2. Let me check either this number is divisible by 7 or not. So far I don't know. Okay, what I will do it simple. This all the digits. Unit place digit is 1 point and remaining all the digits are second point. So let us do this process now. So we have to subtract 5, 3, 7, 6, 3. Twice of the large digit 2 become a 4 now. Okay, do the difference now. Here 13 minus 4 is 9. Here 5, 7, 3, 5. It become a 5. Okay, now this become. Now it is divisible by 7 or not? Even we don't know. So we have to continue the same process again. The twice of the large digit. This and this. That's why twice of the large digit. Now let us continue. 5, 3, 7, 5. Here twice of the 9 is 18. Let us subtract again. So here become a 15. 6 here. That means 7. Here 5, 3, 5. So again we got that 5357. Even this number also we doesn't know either it is divisible by 7 or not. I'll be continuing the same again. Unit place is and remaining all digits. I have divided into two parts. That means 535. The twice of the 7 is 14. Okay, let us subtract this. 5 minus 4 is 1. 3 minus 1 is 2. And here 5. 521. Is this number is divisible by 7? Even I don't know. Let us we go for that the same process again. Here 52. Here twice of the 1 is 2. Okay. Here 2 minus 2 is 0 and here 5. So here 50, we know that 50 is not divisible by 7. 49 is divisible by 7. 50 is not divisible by 7. Else we can complete this. So this complete number, the given number is not divisible by 7. I hope you understand now. Okay. I not you check by taking some other numbers and do this process continuously so that you can understand that which of the numbers are divisible by 7 or which numbers are not divisible by 7. This is the formula you need to remember, that the difference of the twice of the last digit and the remaining digit. If it is multiple of 7 or divisible by 7, then the whole number is divisible by 7. And the last one, divisibility rule of 11. The divisibility rule of 11. The divisibility rule of 11. What is the divisibility rule of 11? Okay, here the divisibility rule of 11 is that the difference between the sum of odd digit places and the sum of even places. So here the difference between the odd places odd digit places and even digit places of a given number. The sum of the difference between the sum of odd digit places and the sum of even digit places of a given number. If it is multiple of 11 or if the number is divisible of 11, then the whole number is divisible by 11. These all divisibility rules are there clearly in your textbook. You can also go for there. These definitions you can get from there. So generally I am telling you to understand the difference between the sum of odd digit places and the sum of even digit places. Their difference, if it is multiple of 11, the whole number is multiple of that means divisible by 11. So let me give you one example here. Let me write any number randomly here. 5, 7, 5, 6, 3, 2, 1, 7, 8. So I don't know either this number is divisible by 11 or not. How can I find? Simple. So alternate numbers we have to take. Odd digit places we will take. Odd digit places in the sense the digit, first digit, third digit, fifth digit, okay, then seventh digit, then ninth digit, like that. See, these are first digit, odd digit places. You take like this. First digit, third digit, and next fifth digit, then seventh digit, then there is no digit here. Okay. Now see, 1 first digit, and this is the third digit. This is the fifth digit. Fifth digit is the odd digit places. Then there is seventh digit, first digit, third digit, fifth digit, seventh digit. These are 1, 3, 5, 7. These are odd digit places. Now we have to take even digit places also. The sum of odd digit places. Sum of odd digit places. Let us take what we get odd digit places. Sum of odd digit places. 8 plus 1 plus 3 plus 5. What will get? 8 plus 1 is 9. 9 plus 3 is 12. 12 plus 5 is 17. Sum of odd digit places you got 70. Now sum of even digit places. Even digit places is not only the remaining here. Second place, fourth place digit, and sixth place digit, and eighth place digit. So now we will also find out the sum of even digit places. What is that? 7 plus 2 plus 6 plus 7. What is the sum of this? Here 7 plus 2 9. 9 plus 6 is 15. 15 plus 7, that is 22. Now we got here, see, the sum of odd digit places and sum of even digit places we got it. And what we need to find out exactly actually the difference between these. We have to find out the difference. Here 22 minus 17. 22 minus 17. What do you get here? 22 minus 17 is 5. Is this 5 is divisible by 11 now? We need to check. 5 is not divisible by 11. Simple. 5 is not at all divisible by 11. Hence, the whole number is not divisible by 11. In this way, we need to check. Simple. Alternate numbers to take it, find out their sum, and then after we find out the difference of the sums. If that difference of the sum is divisible by 11, then the whole number is divisible by 11. Okay, let me write one more number here to understand you again. Let me take one more number. Okay, I will take one more number here. Okay, I don't know even if this number is divisible by 9 or not, 11 or not. Let's take first odd digit places. 9, 7, this and this. Okay, finished. After this, there is no number here. So 9 plus 7 plus 2 plus 7. What do you get here? 9 plus 6, 7, 16. 16 plus 2, 18. 18 plus 7 is 25. Okay, now even digit places. 8, 6, 3, 5. 8, 6, 3, 5. Okay, let's take this. 14, 8 plus 6, 14. 14 plus 3 is 17. 17 plus 5, 22. 20. So now find out the difference. 25 minus 22. That equal to 3. Is this 3 is not divisible by 11. It is not divisible by 11. 3 is not divisible by 11. So the given number is not divisible by 11. So let me get a little change in the number now. Let us find out. Here we are getting 22 now. So here I will write 9. So what I will get here? It is 9. Now find out the number now. Same thing. Odd digit places I did not change. The only even digit place, instead of 6 I have written 9. That means 3 I increased. So that I will get 25 here. So 8 plus 9 is 17. 17 plus 3, 20, 20 plus 5, 25. Now find out the difference. 25 minus 25, that equal to 0. That 0 is divisible by 11, and the complete number is divisible by 11. If it's 0 or 11 or 22 or 33 or 44, if the difference between the numbers, if it is multiples of 11 in the sense, here zeros are not 11 or 22 or 33 or 44. If these kind of numbers if you get, they are called as the multiples of numbers. So multiples of 11. So if the difference of the even odd digit, sum of odd digit places and sum of even digit places, if it is multiples of 11, and the number is divisible by 11 or not is not divisible by 11. So here we have discussed about the divisibility rules of 2, 3, 6, 9, 5, 10, 4, 8, 7 and 11. So to understand you make it these three into the one part. If a number is divisible by 2 and 3 both, then it is divisible by 6. You know the divisibility rule of 2 and 3, then you will also know the divisibility rule of 6. If you remember the divisibility rule of 3, you will also remember the divisibility rule of 9. Same formula will get it. But here we have to check the given number should be divisibility rule of 9 and here the divisibility rule of 3. So 5 and 10, these two will be similar again. And here 4 and 8, these two will be similar. Okay, these two are entirely some different like. Okay, 7 and 11. So this you need to be remember children. And along with this, you have to learn one more thing. What is prime numbers and what is composite numbers. And about prime numbers and composite numbers, already I have done a video. That video link I will keep in the description or not in the icon button. You can see here. If you tap the icon button, there you can see the videos of prime numbers and composite numbers. You have to learn up to 100 prime numbers. There are 25 prime numbers up to 100. How to remember the up to 100 prime numbers? Very easily, I told you in that video. You have to watch the video. That video link I will keep in the description. Please watch that about prime numbers and composite number. Along with that, about factors and multiples also you have to watch a video. About factors and multiple also I have done a video. That video link also I will keep in the description. So along with this video, completely watch this divisibility rule of video. Then after you watch what is prime numbers and composite numbers video, and also factors and multiples of video. That you need to clearly observe. So because this is what our chapter actually, this is will help us. And along with that, LCM and HCF. How to find out the LCM and how to find out the HCF. That also I have done a video. That also you need to be observed. After this, you will get 3 videos links in the description. That you need to be observed very clearly. One is about prime numbers and composite numbers. The other one is about factors and multiples. The next one is about LCM and HCF. So these videos you need to be observed. The videos links will be in the description and also in the icon button. Please observe very carefully so that you can understand. Along with this, after this, we have little to learn again about coprimes. Okay, about coprimes and twin primes. These two things we need to be discussed. Let me tell you that about a coprimes and twin primes. What is meaning of coprimes and what is the meaning of twin primes? When you learn prime numbers and composite numbers clearly, if you know all the prime numbers up to 100, you must know that all the prime numbers up to 100. Then only you can understand this topic now. Coprimes and relative primes. Coprimes are relative primes. Coprimes are, it's also known as a name of relative primes. Relative primes. So let us learn what is meaning of coprimes or relative primes. If you know about the prime numbers, then only you can understand this. If they are given 2 prime numbers, they will give you 2 prime numbers. If 2 prime numbers having only one as a common factor and remaining factors are different, then the prime numbers are known as a coprimes or relative prime. There is a relativity in that. What is the relation? Only the given numbers having one as a common factor and remaining factors are different, because one is a common factor for every number. One is a common factor for every number. So here the remaining factors should be different. Let me write for example here. Only one as a common factor. Suppose 2. Okay. Here suppose 2, and let me write factors of here factors of 9. Let me write 2 and 9 are relative primes or coprimes or not. Let us check. We'll write the factors of 2 now. 1 comma 2. Factors of 2. Factors of 3. So 9 here. 1 comma 3, 9. And see here, only 1 is a common factor and remaining factors are all different. So here 2 and 9 are known as co-friends or relative friends. Okay, let me write one more example here. Then here let me write 15 and I will write 9 here suppose. What are the factors of 15? 1 comma. Here in 15 will also come in the 3 table and 5 table. And also itself is a greatest factor. And also factors of 9, 1 comma, 3 comma, 9. So we must know that how to find out the factors also. Okay, and we should be know that what is about the prime numbers also. Prime numbers and about the factors, about multiples. I have done a video that you need to watch it first. Okay, then here see that 1 is a common factor. Along with 1, 3 is also a common factor here. So these two are not considered as a co-friends. Only 1 should be a common factor and remaining factors should be different. Then only they will be considered as a co-friends or relative friends. So what is the meaning of co-friends or relative friends? If only 1 has a common factor of a given number, then the numbers are known as a co-friends or as relative friends. Only 1 should be a common factor and remaining factors should be different. And here I will tell you one hint. You have to remember, if they are given 2 also a prime numbers. If 2 numbers are prime numbers, they are always co-friends. Prime numbers are always co-friends. This you need to be remember. Prime numbers are always co-friends. Prime numbers are always co-friends. So prime numbers are always co-friends. Suppose if they are given 2 or 3 prime numbers, suppose 2 is a prime number, even prime number. This is 2 is the only one even prime number, and this is the 2 is the smallest prime number, and remaining all prime numbers are odd numbers only. Only one even prime number, that is 2. 2 is the only one even prime number. Remaining all prime numbers are odd numbers only. 2 and 3 and 5. Let us check the factors of 2 and 3 comma 5. 1 comma 2 here, 1 comma 3 and 1 comma 5. What is the meaning of prime number? If a number having only a 2 factor, this is called as a prime number. If more than 2 factors it has, it is called as a composite number. See that these 3 numbers having only one has a common factor and remaining factors are different. Hence, these 2 comma 3 comma 5 are known as a co-friends or relative friends. Simple. So prime numbers are always relative friends or co-friends. Prime numbers are always co-friends or relative friends. But if you get one prime number, one composite number, here 2 is a, suppose 3 is a prime number and 9 is a composite number. Okay, 9 is a composite number, 3 is a prime number. Let's check the factors of 3, 1 comma 3, factors of 9, 1 comma 3 comma 9. So these two are not a co-friends because more than, other than 1 we also have a 3 as a common factor. So these 3 comma 9 are not a co-friends. So if when you get 2 composite numbers, see, suppose 9 and 15 have taken 2 composite numbers. These 2 composite numbers may not be a co-friends always. So they may not be co-friends. If you get 2 prime numbers, always co-friends. If you get 2 composite numbers, they are not a co-friends. But one prime number, one composite numbers, if you get that, you need to check it by find out in factors. If only one is a common factor, then it is a co-friends, or else they are not a co-friends. So I hope you understand this. Next we have to learn about twin friends. Twins. You know meaning of a twins, no? As the same way we have twin friends. Twin friends. The difference of 2 prime numbers. Difference of 2 prime numbers is 2, then the prime numbers are known as a twin friends. The difference of 2 prime number is 2, then the prime numbers are known as a twin friends. So I write here up to 100 prime numbers. See that what I am going to write here: 2, 3, 5, 7, then 11, 13, here 17, 19, 23. 29, 31, 37, then 41, 43 and 47, 53, 59, 59 and here 61, then 67, 71, 73, then 79, 83, 89 and 97. So see that there will be 25 prime numbers exactly. How I have written? You should watch the video so that you can understand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Exactly, these are the 25 prime numbers. If the difference of the two prime numbers if it is 2, then they are known as a twin primes, twin cover. So, twin primes here 5 comma 3. The difference 5 minus 3 is 2. So, this 5 comma 3 is twin primes. 3 minus 2, we get 1. It is not a twin primes. If the difference is 2 of a 2 given prime numbers, then they are called as twin primes. 7 comma 5 is 2. So, 7 comma 5 are twin primes. So, here 11 minus 3, 11 minus 7 is 4. It's not a twin primes. 13 minus 11, yes. 13 comma 11 or 11 comma 13 are twin primes. Okay, 19 comma 17 are twin primes. Here we can understand like this 31 comma 29 are twin primes. In this way we can write which are the twin primes. Okay, if the difference between the two prime numbers if it is 2, then they are known as a twin primes, or else they are not a twin primes. So this is a complete introduction about this chapter actually. So later we will discuss the exercises, but don't forget to watch about the prime numbers and composite numbers video, and about the prime numbers, the factors and multiples video, and also LCM and HCF video. This must and should you need to watch. Then only you can understand the exercise problems very clearly. Okay, thank you for watching this video. Have a nice day.